still. All right, we're officially rolling. Start with any questions?
Yeah, on master set 24, I have a question on part A of question 5.
I am hoping I've got a copy of it right here, but it's possible I'm gonna do my typical walking over there and see what you got. I don't seem to have the master set in front of me.
So it gives an electric field, and then like in vector or in JHAD form, and then it asks what's the plane, or what is the plane in which the plate exists.
Wait, which one are you on?
Number
Oh, 5, okay, sorry, I was thinking 4.
There you go.
All right, three-dimensional space, they have the electric field, very large thin plate, the plane which it exists, and five centimeters from the z-axis. May I take this with me?
Yeah.
X, Y, and then Z coming out at us. So electric field, assuming traditional I hat, J hat. Which, oh, there we go, I do actually state it at this point. So my electric field, negative 25, positive 10, so it's basically going sort of negative 25, positive 10, so my electric field is going in that direction. It's caused by a very large, very thin, almost infinitesimally thin plate with uniform charge density. So I know that if I've got the infinitely long plate, that the electric field is perpendicular to it. So I know that the plate has to be perpendicular to my electric field, so wherever it happens to be. And I know that this distance is 5 centimeters. So there's actually two answers that you could come up with, depending on if you picture this over here or this over here. So in essence, if you can define that line, because it will be true for any value of z, because it's basically it's a plane that intersecting this. Physics 252?
Yeah. Trevor?
Oh, okay. Sorry, didn't recognize you.
It's all right.
All right, so it's a plane that's perpendicular to the XY plane.
Okay.
Is that?
I guess because like it's a 3D vector, I had a very hard time trying to visualize it.
It's not really a 3D vector. I mean, it's a two-dimensional vector here because that's in the XY plane.
Okay. Okay.
This is in the third dimension here, but since it is perpendicular to this vector right here, if I can just define that line in the XY plane, I've defined the plane itself.
Okay, yeah, I was trying to figure out.
Because the value of z does not matter.
Yeah, I was trying to figure out what was parallel to the plate instead of perpendicular to it. So that makes sense.
Right.
And then I also had all of 7. I just forgot how electrons interact with electric fields.
They go the opposite direction.
Like in terms of the value of the electric field.
From number 7. We're calling a different problem here. All right. The electrons released from rest in a uniform external electric field determine which have changed after 1 second. So the electron will move. And then, so recognize that the electron is giving off its own electric field. So, I can't remember, did I specify which direction the field was going in, or?
No.
Alright, so I stick an electron in here. The electron is gonna go opposite the direction. And so after 1 second, it's moved somewhere over here. So the question is, when the electron is now here, what's happening back where it started? Well, you've got this external electric field, which we assume is not gonna change. The electron creates its own electric field, so we've got 2 electric fields at that point right there. The electric field from electrons go towards the electron.
So it takes away from the value?
Yep,
Okay.
at that point,
Okay.
At the point where it originally was?
yes.
That makes sense.
At the point where it's heading, so over here, the electric field's total electric field's a little bit stronger. Because the electron has an electric field going in the same direction when I'm over here.
Oh, for that small segment, like those 3 arrows going to the right are stronger?
So going, right is that way. Yeah, it would be a little bit stronger over here and a little bit weaker over here.
Yeah, because both the fields are going in the same direction for that
Right.
segment.
Yeah.
That makes sense.
Oh, I had a question on one of the questions from the Masterworks of 23. I don't remember what question it was.
First, Vance, was
Yeah.
that,
Yes.
okay.
Thank you.
Oh, it wasn't the Masterworks, it was the conceptual questions, 14. It asked about the state of the equilibrium. I forget if it said it was unstable or stable equilibrium. I still kind of don't understand the difference.
The stable or unstable?
Yeah.
All right. Suppose I have a semicircle right here. Or, just picture a ball sitting on the ground, on level ground. It is possible for a ball to be balanced straight up on top, where it's gonna stay there. Static equilibrium. I could equally have a ball going the other way and a ball sitting in the bottom of it. Both of them static equilibrium. The question is, it's stable. It's a stable equilibrium. If I give a little bit of nudge to the ball here, the ball's gonna go this way, and then it's gonna start coming back, and it's basically gonna stay in the same area. This is stable. Here, if I give it a little bit of a nudge, it's not going back. That thing's gonna keep going. So this is unstable. And this is stable.
So if I have like 2 equal forces coming from both sides, but I nudge one side, will it simply just stay in place on where it was nudged to?
It depends. Because if I've got a positive charge here, and positive charge here, and a positive charge here,
Mhm.
it's being repelled by both of these.
Yeah.
So if I nudge it this way, this force will become dominant, and it will push it back towards the middle. That's stable.
Yeah.
But if I've got that where it's being pulled towards both sides, if I give it a little bit of a nudge, this becomes dominant and it'll keep going.
Mhm.
So that's unstable.
Oh, so for like the problem in the conceptuals, it would also be unstable.
Sorry, what was that again?
So like in problem 14 from the conceptual questions, it would be unstable.
I don't remember 14 specifically.
It's
so-
like it's like it's one charge in the center and then 4 charges in the corners, and the 4 charges in the front of the corners are canceling out the electric field and the forces on the center point, so it doesn't move. So if I were to nudge like the center charge, it would become unstable.
If, is the center charge different from the other 4?
Yes, if I remember correctly.
Alright, so if that's negative, positive, 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 yeah, that would be unstable.
Okay.
But if they were all negatives, then it would be stable?
Yes.
Okay.
And if it is a mix of the two, been. I think so. Then it depends upon which way you nudge it.
So if you went up and to the left or down and to the right, then it would be stable.
Yeah.
But if you nudged it to the bottom left or top right, it'd be unstable.
It would just keep pulling that way.
Yeah. And then there's, so pretty much anywhere in this region is unstable, that's, unstable. I mean, this would be stable along here, because if it got nudged this way, it's gonna get pushed by that, and then pulled by those two, which will pull it
Yeah.
back towards the center.
So as a whole, how would you define that little system there?
How would I do?
Yeah, since it's unstable from certain areas, but stable from the others.
Maybe it was the other class, the 152, where I put in the third choice of, I think I called it semi-stable.
Okay.
If I not, do I need to update the question now?
Well, no, cause ours has like the 4 corner charges are the same.
Okay, okay. Other questions?
On Master Set 23, there was a question where it was, I believe it was aluminum placed on a Van de Graaff or whatever. And it said what will happen to the aluminum.
Right?
I remember that, like when Chance had his hand on it, nothing seemed to happen, but I don't really remember what will happen to the aluminum, I guess. I'm trying to remember, nothing seems to happen physically, but.
Well, and when Chance had his hand on it, some of the hairs, it wasn't dramatic, but some of the hairs did stick up.
Okay.
And I remember when he sat down, somebody commented that some of the hairs are still sticking out.
But
Or maybe I dreamed it, I don't know.
it's a little different, it's different if it's already, on though, so I was kind of wondering what that.
All right, so if I've got my Van de Graaff generator here with a pipe pan on it, if this is positively charged, because I've taken electrons away, what's it gonna do?
Gonna wanna find electrons.
Okay, so where's the easiest source of electrons?
The pipe in.
All right, so it pulls electrons from the pipe pan and gets rid of those. So now what?
They're both positive.
Therefore,
So it'll go from there.
yeah.
Okay.
And I dream that someday I can do this demonstration and it will hover, but it won't. It has to be perfectly lined up. It's an unstable equilibrium.
I was gonna say, it needs to be
What if
a
you-
stable equilibrium.
Turn it upside down.
That might work.
Hold the Van de Graaff generator upside down.
Maybe it's to hold the pipe hand in place. That sounds safe.
It'll push the pipe pan back to Earth.
What if you lower the charge of the generator?
Sorry?
What if you lower the charge of the generator?
It's still, in order, if I turn the belt down so it's not quite as powerful, it's still gonna pull electrons from the pipe pan. The pipe pan is still going to come up. And once it comes up, if it's not perfectly balanced, it's just gonna slide off or hover off.
There's a way, we just gotta figure it out.
There are a bunch of future engineers here.
All
Once
right.
you solve the upside down room problem. I can't remember, I can never remember if I did a video on that. The 251, anyone remember?
I don't think so.
Oh, was it the one with the person walking on the wall?
No, it's that, to me, a great April Fool's joke would be to walk into a room and everything is upside down. But it's an engineering issue because you've got these type ceilings, which really aren't gonna take the weight of something like this, so. But it also has to be done very quickly to set it up. So it's an engineering problem that I pose to students.
So
Even when I was teaching elementary school a number of years back, I posed it to them also. And I'm hoping it just sort of worms its way into a couple of the students and they eventually figure it out.
So you're saying if we ever have a class with you during the month of April, that you would be like pleasantly surprised.
I would be pleasantly surprised if the whole room was upside down. All the furniture on the ceiling and like, we can leave those pictures there, but it's all the tables upside down on the roof or the ceiling.
What if we damage something in the process?
That's on you. Anyway, other questions?
I mean, we could try to screw a bunch of stuff in, but we'd have to replace all of that. That's too
Yeah.
weak.
This is not gonna hold it, it's a drop-in Armstrong ceiling, but above it, there's a whole concrete pad, and then all these lights, fixtures are being anchored for the concrete pad through a bunch of Hilti mounted, these like long aluminum things, so you could like Hilti gun up a bunch of more of those aluminum drop downs, and then just tie everything onto that, but then you would still have to cut through the drop-in ceiling.
Well, that's okay, we don't worry about the ceiling.
Well, we can cut it out, yeah.
You know, I might laugh. I'm not sure everyone would.
Yeah, but I think it would go viral. and then
We have to buy a
get
lot of
money.
construction equipment to get this done.
It would take a lot.
I think you would have to do a lot of prep beforehand, you know,
Yeah.
to get all the anchors in place, so it's just a matter of turning the desks. Or find out when the last class is in that particular room.
Well, when's the
Lock
last
out the
class?
door, window,
Kick the teacher out.
well, it's after the last class.
No, not during.
No, probably not during. Sorry, I just pictured going to my office for a minute, and coming back and everything's upside down. I would give everyone in this class A's if you could do it in a minute.
Hey, that'd be worth a shot.
Or perhaps we should talk about physics and,
Yeah, try.
Yeah.
all right, other questions?
So it's from Master Set 23. It's talked about, two neutrally charged, I guess not charged, two neutral metal spheres touching,
Okay,
and then you bring in a rod, an insulated rod that's positively charged,
right.
and you touch one end of one of the spheres. What, it's probably super basic, I'm just overthinking it, but, I'm guessing the electrons from the first sphere go into the rod,
Yep,
because it wants to make that neutral, right?
right. And in a localized area, but it'll still pull some electrons,
So then that makes sphere A positively charged,
right?
and then you pull the rod away. What happens after that?
Well, they're two conducting spheres, so we have a positively charged sphere now, so what is it gonna do?
Is it gonna pull electrons from the other sphere
Yep,
until they're kind of evenly positive?
yes.
Okay,
And
gotcha.
And then the magic happens.
Okay, that's what I had. I just wanted to kind of make sure, so,
Spot on.
because I am doubting myself.
In physics, how could anyone doubt themselves?
It's very easy.
We not doubt ourselves?
Oh yeah, we're supposed to believe that we're better than everyone else.
Yeah, don't doubt yourself in front of other people.
Oh, just in alone in silence.
Yeah, that's when the tears, but the tears flowed in. Other questions? All right, let me do a little, background on the lab that we're doing today. Not in this room. Go on.
Which question did you ask about too? Or which question was it?
Hmm?
The one that you asked about?
That was Master Set 23, number 2.
All right. I'm not gonna go into, a lot of the background that I would normally do, because there are videos on it, I'm not gonna repeat them for the most part. But we talked about the electric field exists by just a single particle, and that's how another particle knows, well, in my universe with just a proton, it's giving off this electric field, that if I throw another particle into that universe, it would sense the electric field and know something else is there, and react to that. Though the electric field and the force, both vector quantities, And there's energy also, the system has energy, and very similar to the gravitational potential energy, except without the minus sign, the electric potential energy, KQ1, Q2 over R. The generalized gravitational potential energy was negative big G in 1 and 2 over R. So I've got this quantity here with, requires 2 charges, got a quantity here with 2 charges, got a vector quantity here with 1 charge. There's also a scalar quantity with only 1 charge, and that's called the electric potential. I guess officially plus a constant. And the constant is decided by where you're going to establish 0 to be. Now the potential, so if I have a positive charge here, and let's make it so the math works out more nicer. So I have some charge here at Q, which is 3 nanocoulombs. If I'm 1 meter away, I can figure out the electric potential, but I do need to state that V equals 0 at R equal to infinity. If V equals 0 is at R is equal to infinity, what is the constant?
0?
Yeah. So that would establish that is 0.
And what does V represent?
Electric potential.
Okay. So both of those equations are for electric potential?
That's a U there. This is electric potential energy. You said both those equations.
Gotcha.
Like this equation here
Mm-hmm.
and that one? Is that the
Yes.
other? Yeah, this is energy. This is, there's a difference between electric potential energy and electric potential.
Is electric potential like voltage? And then,
It's related to it. It is not voltage directly.
Okay.